Soil is a mixture of organic matter, minerals and gases, liquids, and organisms that together support the life. Soil has been called the skin of the earth. Soil is a product of the influence of the climate, relays, organisms, and its environment materials. The soil science has two branches of study, earthology and pedology. The soil is made up of different layers that are called horizons. Each layer has its own characteristics that makes it different from all the other layers. The first one is the horizon, that in the image is a O. This is the top of the layer of the soil that is made up of living and decomposed materials like leaves, plants, and bugs. This layer is very thin and it's usually pretty dark. The other A is the layer that we call topsoil, and it is located just below of the whole horizon. This layer is made up of minerals and decomposed organic matter, and it is also very dark in color. This is the layer many plants roots grow in. Then it's the B horizon. This is the layer that we can call subsoil, and it is located just below the A horizon. This layer has clay and mineral deposits or less organic minerals than the layer above it. This layer also is also thinner in color and layers above it. Then the C horizon, this is a layer that we call radiolite, and it is located just below the B horizon. This layer is made up of slightly unbroken rock and only a little bit of organic material is found here. Plants, roots are not found in this layer.
Erosion can be caused by many factors, including human intervention, as tunneling or overcropping, and the most common one, climate change. Consequences of this erosion are most normally lower yields and higher cost production in agriculture. Solutions for this problem are reducing the areas where agriculture is taken and naturally taking care of environment. Desertification is caused by a combination of factors that change over time and vary by location. These include indirect factors such as population pressure, socioeconomic and policy factors, and international trade, as well as direct factors such as land use and practices and climate related processes. These factors lead to decreased land productivity and degradation and poverty. Where conditions permit, dryland populations can avoid degradation by improving their agricultural and grazing practices in a sustainable way.
When carbon dioxide (CO2) is absorbed by seawater, chemical reactions occur that reduce seawater pH, carbonate ion concentration, and saturation states of biologically important calcium carbonate minerals. These chemical reactions are termed ocean acidification, or OA for short. Calcium carbonate minerals are the building blocks for the skeletons and shells of many marine organisms. In areas where most life now congregates in the ocean, the seawater is supersaturated with respect to calcium carbonate minerals. This means there are abundant building blocks for calcifying organisms to build their skeletons and shells. Ocean acidification is expected to impact ocean species to varying degrees. Photosynthetic algae and seagrasses may benefit from higher CO2 conditions in the ocean, as they require CO2 to live, just like the plants on land. On the other hand, studies have shown that the more acidic environment has a dramatic effect on some calcifying species, including oysters, clams, sea urchins, shallow water corals, deep sea corals, and calcareous plankton. When shell organisms are at risk, the entire food web may be at risk. Today, there are more than a billion people worldwide that rely on food from the ocean as their primary source of protein. A way that we think we can solve this problem is by stop letting all our chemical wastes go to the sea instead of searching a way to purify that water or that liquid wastes of the industry that we have today in the world.